So a population, and again this is kind of basic, but a population is a group of individuals in a single species living in the same area. So let's say you had like an area over here, an area over here, and an area over here. It'd be all the individuals in each one of those little areas would be a population. So each one of these is a population. This is like the basic understanding of what a population is. And ecologists try understanding how biotic and abiotic factors influence density, distribution, size, and age structure of populations. Biotic being living factors, and abiotic being non-living factors. Water, rock, wind, sun, those would all be abiotic. And biotic factors are all living. And then a population inhabits the same general area, these little circles are the general area, and possess a constant and uniform density and dispersion. The density of a population is the number of individuals per unit area or volume. So like on the last slide where you have all these little circles, all these are going to be the populations, but like this population over here could be more dense because there's more animals or trees or whatever's in the population in that area than what would be in this one or this one. So this would be less dense than this one would be less dense than this one. So that density is basically just exactly how it sounds, whichever one has more and the area is more dense. And ecologists use techniques such as finding a number of animals in a small area, then multiplying it to equal the big area. So to find the amount of animals in an area that is in this area over here that is dense, they would take like just a little sliver of it, find out how many animals are in this area, and then multiply it to get the bigger area. So the mark recapture method is another way that ecologists are able to figure out how many animals or individuals are in a population, and they calculate the births and immigration of animals, which will add to the population, and then they calculate the deaths of and immigration for animals decreasing the population. The difference in this immigration and in this immigration is this immigration would be animals leaving. That's the type of, with the E is animals leaving, whereas immigration with an I over here would be animals entering. Dispersion is the pattern of spacing among individuals within the boundaries of the population. So that's how, again, let's say we have our boundaries, and then the dispersion would be, let's say over here, in this side of the population is dispersed uneven because this side is a lot more, whereas over this side there's fewer. That's also kind of it runs hand in hand with density, and how dense they are is how they're dispersed throughout the population. So they're either going to be dispersed, you can have them real close, or they can be pretty far away. That all has to do with dispersion. Now there are different types of dispersion. You have clump dispersion, which is where they're really close together. All the individuals are really, really close together in clump dispersion. You have uniform dispersion, which is where there's an equal space. I'm going to try as best I can to get an equal space between each one of these as I can. And then there is random dispersion, which they're just randomly throughout the population. They're just dispersed randomly, just like it sounds, obviously. Now, demography is the study of the vital statistics of populations and how they change over time. And one of the big effects on this is birth and death rates. And charts and curves are usually drawn to easier see demographics, and this is also in the book. But it goes into more detail on how to draw each chart in the book. It's kind of hard to put on here, but it basically uses the curve like we learned in pre-cal or any of those math classes. It uses the curves to determine the demographics and the survival patterns. So, for example, like on the type 1 curve down here, a flatter curve would suggest a lower death rate in the middle of their life, and then a higher death rate as they get older. So let's say you have a lower curve. You have like a little chart here. Let's say you have a flat curve. It would suggest that like through the beginning of their life, and then right through the beginning of their life, it's a low death rate, and then the curve has to go up eventually, and that's when the higher death rate occurs. Because as they're getting older, just as we do as we get older, you just naturally die as you get older. A type 2, and this is a type 1 curve, by the way. A type 2 curve is like an intermediate curve, so that is basically, it's constant the entire way. So it'd be more of a straighter line, and that pretty much shows a constant death rate over a lifespan. You can die kind of whenever, basically. The death rate it isn't any different any time. Now, ecologists and demographers who usually study sexually reproducing species generally focus on only the females, because only the females can reproduce offspring. So for the essential to demography, which has to do with the birth and death rates, well, obviously that has to do with the females because they're the ones that have the offspring. So they really try to focus on generally the females, and they can get a good idea on the demography of a population just strictly off the females. And the cohorts, and they talk a lot about cohorts in the book. And a cohort is just a group of individuals of the same age. So like we would be cohorts with each other because we're the same age, and we're growing up together. And so that's how the life table, or the reproductive table, and the life table, and those curves, that's how they work. They take a group of cohorts, and that's what the chart is based off of. And also a really important thing to notice, I'm going to star this here and then circle it for extra emphasis, but is that a high reproductive rate will not lead to rapid population growth unless conditions are near ideal for growth and survival of the offspring. That's really important because people tend to think, well, if they have a high reproductive rate, then then the population will increase faster. Not necessarily, because if you think of it, like how many acorns will a tree drop in, but how many of those actually turn into trees? Or if you've ever stepped on a spider that has one of those nests on its back, and all those little spiders are running around, and most of those won't survive because the conditions aren't ideal for all of those to survive. It's competition to survive. And that's the end. And I apologize for making it almost 8 minutes, but thank you for your time.